All right, so this is the visual aid video for trapezoids and kites so that you can see where the properties that I'm going to talk about in the notes, and you can see where they come from. We're going to start with the isosceles trapezoid. And so what I've got here for you is just I've made an isosceles trapezoid. This side AB and this side CD are the parallel sides. And then I've shown how long AC and how long BD are. They're both 3.2. That's to show you that it's an isosceles trapezoid because AC and BD are the non-parallel sides. And to make this an isosceles trapezoid, the non-parallel sides have to be congruent. So that's why I did that. Now, what I'm going to show you here is because we're going to talk about angles with the trapezoid. And I'm going to measure a bunch of angles. So let me find the angle measure tool. And let's measure this first angle. So it's saying that this angle, let me move it, is 71.6. And let's measure this same one over here, the one that we would call angle B. And I'll move it where you can see it. Okay? So notice that pair of angles is the same. They're congruent. And that's not a coincidence. Those are called base angles because they touch the same base of the trapezoid. And in an isosceles trapezoid, the base angles are congruent. So these two on the same base are going to be the same. It'll also be true for the top base. So let's go look at that one. So A, C, D. Oh, I didn't click it. There we go. A, C, D, then C, D, B. And so notice both of these are the same. And so that will always happen with an isosceles trapezoid. The two pairs of base angles will be congruent. So the two down here on the bottom and the two up here on the top, they'll be congruent to each other. Notice that the ones on the same side, if you added those two together, 108.4 plus 71.6, you would get to 180 degrees. Because they're on the same side, they're supplementary. Notice if you go across, notice that they're the same again. Like this is 108.4, this is 71.6. It's the same relationship as on the side, but now it's across. So an extra property here is that the opposite angles of an isosceles trapezoid are supplementary as well. Okay? So that's the isosceles trapezoid. Let's go look at a kite. So I've made a kite here, and I've measured every side because remember, a kite's definition is that it's a quadrilateral with two pairs of congruent sides. And those sides are not parallel. So notice the top two sides are about 2.2, and the bottom two are about 4.5. So the first thing we're looking at for a kite, we're going to look at where the diagonals intersect each other right here. I want to measure all those angles right there, or at least two of them. And you could probably figure out what the angle measure is going to be just by looking at it. And if you were thinking they were 90, you were right. And so we say that the diagonals of a kite are perpendicular. Okay? When they intersect each other, they form 90-degree angles. So that's a very important thing to remember, that those angles in the middle are 90. Now I want to look at another property of a kite. Another property with a kite, it says that it has exactly one pair of opposite angles that are congruent. And so just visually looking, now you're going to have to look past the diagonal and look at the entire angle at every side, okay? It's kind of hard to see with the diagonal drawn in, but if you look at A, the angle opposite him would be B. Well, there's no way in the world those are congruent because this is smaller, this is bigger. So I wonder if it's this pair, C and D. Let's look. So A, C, B. Well, that turned out to be 90. Okay. Now, just because it's 90, don't be like, that's not like the important thing I was talking about there. Just the way I've drawn the kite, it happened to be 90. But the thing I want you to see is they're the same. Okay. These angles that are on the shorter diagonal, that's what I tell myself. If they're on the shorter diagonal and they're between the short sides and the long sides, between the 2.2 and the 4.5, the angles in between there, this pair of angles right here will always be congruent in a kite. Always. They may be 90, they may be 100, they may be 45. You don't know, but they will always be the same. And now for the last property of a kite is we're going to look at the longer diagonal. What happens to it when it touches the angles? Well, let's find out. So first I'm going to measure this entire angle up here. So that whole angle was 126.9, roughly. Now I'm going to measure each little piece. So let me scooch everything out. Let me hide that because we don't need them anymore. Okay. Oops, I hid the wrong one. Undo. Undo. Whoops. Okay, sorry about that. I was trying to move stuff around so you could be easy to read, and I ended up deleting too much. So, anyway, ignore this 90. This entire angle A up here was 126.9. And then each little piece was 63.4, which I know if you add those up, it doesn't exactly get to that. That's because of how this program is set to round. But the point is that this entire angle A has been bisected by the diagonal. The entire measurement was cut in half, and it should happen for the other angle that is opposite him. So let's see. So that whole angle is 53.1. Now let's measure its little pieces. I'm going to scoot them out where they need to go. And so this entire angle down here was 53.1, and each single piece was 26.6, which when you add those up gets you back to the 53.1. So the property for the longer diagonal of a kite is that it bisects the pair of opposite angles that are not congruent, if that makes sense. See, this pair that I have is 90 right here and right here. They're opposite each other, but they're congruent. The 126.9 and the 53.1, they are opposite each other, but they're the not congruent pair. They're also the pair on the longer diagonal. So that pair on the longer diagonal is going to be bisected by that longer diagonal. Okay? So that's the visual aid video for trapezoids and kites. Make sure you watch this through and then go watch the notes video so that you understand how to use the properties.